All right, welcome back to chemistry drills. Today we're doing drill 7. The unanswered drill will be in the description as well as the drill with all the answers on it. But let's just jump right in. The value of X in FeNH42SO4 XH2O can be found by determining the amount of mole of sulfate in the compound. So right away, I noticed that we're identifying sulfate in our compound. A 0.982 gram sample was dissolved in water and excess barium chloride aqueous was added. The precipitate of barium sulfate was separated and dried and found to be weigh 1.17 grams. A. Calculate the amount in moles of barium sulfate in the 1.17 gram of precipitate. So this first part is just straight up stoichiometry. We have 1.17 grams BaSO4, and we are converting that into moles. So 1 mole of BaSO4 is equivalent to 233.39 grams BaSO4. This mass right here, 233.39, is just a combination of the molar mass of barium, barium plus sulfur plus 4 oxygen masses. With that, when we solve this all out, we get an answer of 5.01 times 10 to the negative third mole barium sulfate. All right. Now going on to part B. Calculate the amount in mole of sulfate in the 0.982 gram sample of our sample. I'm not going to resay it all. So with that, we kind of have to go back to our text and see what was happening. Well, we know that we took our original sample, we dissolved it, reacted with barium chloride, and all of our sulfate precipitated in our barium sulfate. Therefore, the moles of barium sulfate we can use to get the moles of sulfate. And because we can see that barium sulfate is 1 barium, 2 plus, and 1 sulfate, 2 minus, the moles should be equivalent. So if we have 5.01 times 10 to the negative third moles of barium sulfate, we will have 5.01 times 10 to the negative third mole of sulfate, SO4 2 minus. Moving on to C. Calculate the amount in mole of iron in the 0.982 gram sample. All right, so we have to take a look at our sample. FeNH4 2 SO4 2. Some amount of water because it's a hydride. So we notice that if we have 2 sulfates to 1 iron, then we can do 5.01 times 10 to the negative third mole of sulfate for every 2 mole of sulfate. We have 1 mole of iron. So mole sulfate, and turns out we get an answer of 2.5 times 10 to the negative third. Closer to 2.50 times 10 to the negative third. No, you know what? Sorry, let me go back on that. 2.51 times 10 to the negative third mole of iron. All right, so we're never really using our original mass, and we will continue to not use our original mass because our original mass describes this sample, but the problem with the sample is that it has an unknown amount of something in it, therefore we can't do any stoichiometry with it yet. So determine mass in grams of the following present in the sample. So iron. Well, we know we have 2.51 times 10 to the third, negative third, mole Fe. we just do a simple molar mass. 1 mole is the same as 55.85 grams. And we will get an answer of 0.140 grams iron. For 2, we're looking at ammonium. You may notice that in our sample for 2 sulfates, we have 2 ammonium. It's a 1-to-1 ratio between those two. So we can actually keep our sulfate, 5.01 times 10 to the negative third, the same mole. And we just have to do the math. Again, it's 1 mole. Oh, I should rewrite this. And I should write the one above, correct it, because they need to be flipped. My apologies. It is, sorry, 14.04 grams. Or sorry, I'm getting this all mixed up. 17.03 grams for 1 mole of ammonium. This is what happens when I stop writing the actual compounds. And we will get a total of 0.0653 grams ammonium. Lastly, our original component, the sulfate, 5.01 times 10 to the minus third mole of sulfate, SO42 minus. That is going to be 1 mole on the bottom and 96.06 grams on top to give us a total of 0.481 grams sulfate. Apologies for not sticking with the color convention that I have established. But there is our answer. And then finally, E. Really not sticking with it. E. Use your answer from part T to determine the amount of mole of water present in the original 0.982 gram sample. So if we take 0.982 grams and we subtract the sum of our other masses, 0.140 plus 0.0653 grams plus 0.481 grams, we will get an answer of 0.0164 grams of H2O. And there it is. That is it. Hopefully this helps, and have a good night.